Okay, so now what we have now is we have sand that's piling onto a conical pile. And so we have a pile that's building up, so the volume's getting bigger. And it's asking us at what rate is the height of the pile changing at the moment that the pile is 15 feet tall. So again, we're going to use our volume equals 1/3 pi r squared times height. So we have volume is 1/3 pi r squared times height. Alright, so what we know is dV dt equals 10 cubic feet per minute. So the pile is growing by 10 cubic feet every minute. dV dt equals 10. And then we know that the diameter of the base of the cone is approximately 3 times the height. So we know that diameter equals 3 times h. Okay? So we know that the diameter is 2 times the radius. So we have that 2 times the radius is equal to 3 times the height. Alright, before we figure out if we're going to substitute in, we're either going to get rid of r or h up here. We have r's and h's down here. We need to know what we know. So, alright, so we're looking for when it's 15 feet high. That's the height. So we're going to want to keep h involved because we know h. We know that h is eventually going to be 15 feet. So we're going to get rid of our r, so we'll solve for r. We get that r equals 3/2 h. So that's what we're going to plug in to our volume equation. So we have volume equals 1/3 pi r squared. Oh, that's r. We're trying to replace that. Let's also make that pi better. Okay, so 1/3 pi times 3/2h squared times h. This is where you have to be kind of careful with algebra. This is v equals 1/3 times pi times 9/4h squared times h. Okay, we have to square everything that's in that parentheses. So we square the 3, we square the 2, we square the h. So let's simplify. Alright, we're going to get 9/12 when we multiply our coefficients here, our constants. So 1/3. 1 times 9 is 3. 3 times 4 is 12. So we get 9/12, which is 3/4. Okay, 3/4 pi, and then times h cubed. Okay, that is our new volume equation with radius substituted out for its relationship with height. So now let's find dV dt. We know that the derivative of volume with respect to time is going to be equal to, alright, we have to do a power rule on that h, so we're going to get 9/4 times pi times h squared dH dt. Alright, and now we have to use our given information. We know that height is 15 feet. They give that to us. And we know dV dt is 10. So we're going to substitute in 10 for dV dt equals 9/4 times pi times 15 squared. And that's multiplied by dH dt. dH dt is what we want, so we have to isolate it. We want the change in height with respect to time in our given scenario. So what we're going to do is we're going to divide everything out. We're going to divide by 9/4 pi times 15 squared. Okay, so let's be a little bit savvy about this. When we divide by 9/4, that's the same as multiplying by 4/9. So that's going to give us 40/9. And then we're dividing by pi times 15 squared, 2, so that's going to be in the bottom 2. Pi, and then 15 squared. And then that's equal to dH dt. So we just have to simplify this now. So 15 squared is 225. So then we have 225 times 9 on bottom, which is 2025 pi. So this equals 40/2025 pi. And then I'm sure we can simplify that. Let's see, what's going to go into 2025 that also goes into 40? So 2025 divided by, that's not going to work. We got 2. Right. Obviously 5 goes in. Okay, so 5 goes into both. So 40 divided by 5 is 8. And then 2025 divided by 5 is 405. So this is going to simplify as, our final answer is dH dt equals 8 over 405 pi. Which you can just type that into a calculator to get a decimal approximation, but this is saying how quickly the height is changing when we know the volume's changing at 10 cubic inches per minute, and we know we're looking for the instance when the height is 15 feet. This is how much the height is changing. It's changing by 8 divided by 405 pi feet per minute.